Welcome to China Connect, your fun guide to real China. Explore and uncover its intriguing stories. Let's go. Today, we're going to talk about something extraordinary, something that's happening way above us, in space. It's not aliens, not yet, but it's pretty damn cool. It's about rockets, specifically, methane-oxygen rockets. So buckle up, and let's dive into it. 3, 2, 1, ignition. That's not the start of a new game, but the launch of the zhuque 2, a methane-oxygen rocket made in China. On the 12th at 9 a.m., this rocket, developed by LandSpace Technology Corporation Limited, shot up into the sky from the Zhuque Satellite Launch Center in China. The launch was successful, the rocket entered its intended orbit, and the mission was a complete success. Now, this isn't just any other launch. Zhuque 2 is the first methane-oxygen rocket to ever make it into orbit. This means that China just scored a major breakthrough in the application of a new type of low-cost liquid propellant. The success of Zhuque 2 has also validated the rocket's various systems, laying a solid foundation for the next phase of reusable rocket development. Let's look at the specs of this bad boy. The Zhuque 2 is a two-stage rocket that uses methane and liquid oxygen as its propellants. It has a body diameter of 3.35 meters, a total height of 49.5 meters, a takeoff weight of 219 tons, and a takeoff thrust of 268 tons. Its fairing, which is the shell at the top of the rocket that protects the payload, has a maximum diameter of 3.35 meters and is 8.237 meters long. The first stage of the rocket uses 4 parallel zhuque 80-ton class methane-oxygen engines, while the second stage uses a combination of 1 zhuque 80-ton class methane-oxygen engine and 1 zhuque 10-ton class gimbaled methane-oxygen engine. Zhong Changwu, the CEO of LandSpace, revealed that even before the launch of Zhuque 2, the Zhuque 3 rocket had already entered the assembly stage. Given the success of the Zhuque 2 mission, LandSpace aims to make small batch deliveries to the market in 2024, with 3 to 4 launches that year and double that number in 2025. And here's another cool thing. LandSpace has kicked off a project for a reusable rocket, which they expect to make significant progress on by 2025. When LandSpace was founded in 2016, it began to consider making its own rocket engines and launch vehicles. And one of the key questions facing LandSpace decision-makers and engineers was what combination of fuel to use for their future commercial rockets. Methane, as compared to kerosene used in space travel, can be produced in large quantities industrially and is cheaper. Its liquid state is at a similar temperature to that of liquid oxygen, so the requirements for handling and maintenance are similar. Moreover, the combustion products of methane are clean, with no soot accumulation, which means the engine doesn't need cleaning after use. This makes it much more suitable for reusable rockets than other propellants. So, methane is a pretty good choice for a commercial rocket propellant. Now, let's talk about engines. Engines are kind of like the heart of a rocket, and LandSpace has made significant breakthroughs in their development. The zhuque engine series used in Zhuque 2 have completed nearly 100,000 seconds of ground testing, making them one of the most mature liquid rocket engines in China. It's worth noting that earlier this year, 2 methane-oxygen rockets from the American company Relativity Space failed in their first attempts to enter orbit. So, with the successful launch of Zhuque 2, China's LandSpace has achieved a globally leading technological level. The term liquid rocket refers to a rocket that uses a liquid propellant as its power system, as opposed to a solid rocket, which uses a solid propellant. Compared to the solid propellants and liquid oxygen used in mainstream rockets, as well as other alternative fuels, methane is considered a cleaner and more economical choice. Compared to other solid, liquid oxygen kerosene, or liquid hydrogen liquid oxygen engines, methane-oxygen engines have higher propulsion efficiency, no soot accumulation when the propellant is burned, significantly reduced insulation requirements, and methane fuel can be separated from natural gas, oil-field gas, combustible ice, etc., making it widely available and cheap. This can further reduce the cost of rockets, making it very suitable for reusable rockets or aircraft. But the success of zhuque too didn't come easy for LandSpace. After the company was founded, it made several advanced technical attempts, but experienced several failures. In October 2018, LandSpace Zhuque-1, the first privately developed rocket in China, was launched from the Jiuquan Satellite Launch Center. However, the satellite that the rocket was carrying failed to enter its intended orbit, and the mission was ultimately a failure. Following the failure of the Zhuque-1 launch, LandSpace shifted its focus to methane-oxygen rockets, hoping to achieve a technological leap with liquid methane rockets. In December 2022, LandSpace launched its independently developed Zhuque-2 methane-oxygen rocket for the first time from the Jiuquan Satellite Launch Center. However, due to an abnormal shutdown of the second stage main engine after shutdown, the mission failed. Methane is a typical, double cryogenic, propellant combination. Facing methane, this newborn, problems can easily occur during its cooling, heating, pressurization, and transportation processes. To solve this problem, LandSpace engineers came up with an idea. They used the excellent cooling properties of methane to cool the combustion chamber of the Zhuque-2's rocket engine. After the methane passed through the cooling channel of the combustion chamber, it became gaseous. Some of this gaseous methane could then be drawn off to solve the problem of gas supply. This autogenous pressurization, as it's called in the rocket field, is like a child blowing air into their milk bottle while drinking, perfectly solving the problem of gas replenishment in the bottle. In the process of developing the Tianqiu engine and the Zhuque-2 rocket, LandSpace has made a great effort to use as many civilian products as possible, aiming to make the previously sacred spacecraft more accessible to the public. When choosing the rocket's power technology path, LandSpace boldly chose natural gas, a common civilian fuel, as the rocket fuel. Whether it was frequent engine testing or fueling for launch tests, methane could be supplied at any time and anywhere, avoiding supply risk. The rocket also uses many general-purpose shelf components, such as standard parts, electrical switches, and some sensors. Introducing many private enterprise suppliers that had never been involved in the space field before, and bringing common industrial processes, materials, and equipment into the development and manufacturing of space engines. These continuous innovative measures make it possible to reduce costs by an order of magnitude. Currently, the rocket engines with independent intellectual property rights developed by LandSpace have achieved 100% social supply, and the substitution rate of industrial products, shelf products, and self-developed products in rocket bodies and avionics systems is gradually increasing. This not only helps to reduce costs, but also ensures the supply safety of mass-produced rockets. Reducing the risk of being strangled by supply shortages, LandSpace's next goal is to use stainless steel instead of aluminum alloy to manufacture rocket tanks. As a bulk industrial product, stainless steel is easy to obtain, cheap, and easier to process. Using stainless steel, a civilian material, makes the dream of making rockets like cars no longer just a dream. Making civilian products meet the requirements for space travel is not an easy task. LandSpace has undergone a long and rigorous trial and verification process in the process of introducing industrial products to manufacture rockets. Since its establishment, the company has attached great importance to the co-growth and progress with its suppliers. LandSpace provides suppliers with road support, professional guidance, and shares road costs, promoting suppliers to tap their road potential and promote product upgrades. Currently, LandSpace has established a stable, continuous, and independently controllable commercial supply network, with more than 350 suppliers, 67% of which are private suppliers. Some of these companies had no previous experience in space support and lacked understanding of space quality standards. To address this, LandSpace has established a complete set of digital supply chain management tools to achieve real-time synchronous interaction of key information with core suppliers. So, there you have it, folks. China's LandSpace is making some serious moves in the world of rockets. And the successful launch of zhuque 2 marks a significant milestone in the use of methane-oxygen rockets. It's a whole new era for space exploration, and I, for one, can't wait to see what comes next. Thanks for joining our China journey. Like, comment, share, and subscribe for more. Drop your questions or ideas below. Let's keep exploring this fascinating nation together. See you in the next video.